Student. I think you are doing well. I am ABM Moinul Islam, Associate Professor, Department of Mathematics, Raju Gutra Model College. Today I will discuss for the student of class 9 English version, and today I will discuss on mathematics. Now we will discuss on chapter 16.1. In the chapter, there are different formulas to find out the area of different kind of triangles. Such an example, if ABC is a triangle and its base and height are given, then area of this triangle will be half into base into height, that is half into BC into AD. Again, if any and if the length of any two sides of a triangle are given and their included angle is given, in that case also we can find out the area of the triangle. Such an example, if in this triangle AB and AC are given and angle A is given, in that case its area will be half into AB into AC into sine angle A. Similarly, if AB and BC and their included angle B is given, then their formula will be second one, area half into AB into BC into sine B. And if two sides AC and BC are given and their included angle C is given, then area of that triangle will be half into AC into BC into sine C. Again, if length of three sides are given but no included angle are given, in that case area of the triangle will be root over s into s minus a into s minus b into s minus c, where s is the half of the perimeter, that is s is equal to a plus b plus c divided by 2. Again, if a is the length of each side of an equilateral triangle, then area of equilateral triangle is root 3 by 4a square. We will prove this formula later. Again, in an isosceles triangle, if the length of two equal sides is a and the base is b, then area of that triangle will be b by 4 and root over 4a square minus b square. Now, last two formulas, that is formula number 4 and formula number 5. Now we will prove, because the proof of those two formulas are very important. So okay, now we go for next slide. So here question is, if the length of each side of an equilateral triangle is a, then it is equal to prove that area of that triangle is root 3 by 4 a square. You can see that here ABC is a triangle, equilateral triangle, whose length of each side is a. So now we will find out the area of this triangle. So in first formula, we saw that area of a triangle is half into base into height. So here half into base means BC, here BC is A. So we only find out the height of this triangle, that is we will find out AD. So length of each side of this circular triangle is A. Therefore AB is equal to BC is equal to AC is equal to A. Now from point A we draw perpendicular AD on BC. So we know if AB and AC are here equal, and if we draw any perpendicular from the vertex to the base, in that case this perpendicular will bisect the base, that is here BD is equal to DC and is equal to A by 2. So now in right angle triangle ABD, you can see that according to Pythagoras theorem, we can write AD square is equal to AB square minus BD square. We can write this according to the Pythagoras theorem. Here AB is equal to A and BD is equal to A by 2. So if we put these values, then finally AD square becomes 3A square by 4, and finally AD is equal to by square root we get root 3A by 2. So Finally, area of triangle ABC is equal to half into base into height, that is half into BC into AD, that is half into the value of BC is A, and just now we find out the length of AD is root 3A by 2. Then finally we get the area of this triangle is root 3 by 4 A square. Okay, now we are going to next slide. So here we will prove the formula to find out the area of an equilateral triangle. Isosceles triangle. Here length of two equal sides of an isosceles triangle is A, and the length of its base is B. Then we will prove that the area of this isosceles triangle is B by 4 root over 4A square minus B square. You can see that here ABC is an isosceles triangle whose two equal sides AB and AC, whose length is A, and here BC is B. Now we draw a perpendicular AD from vertex A on the base BC. So here also AD bisect AB. Here AD bisect BC. So therefore BD is equal to DC is equal to B by 2. So similarly here also we will find out the length of AD, and finally area of this triangle will be half into base into height, that is half into BC into AD. So similarly from the right angle triangle ABD, according to Pythagoras theorem, we can write AD square is equal to AB square minus BD square. Here the value of AB is A. From the figure you can see that, and BD is B by 2. So by putting these values, we get the value of AD square is 4A square minus B square divided by 4. So by square root, we get the value of AD, and which is root over 4A square minus B square divided by 2. Then finally, the area of the triangle ABC, which is isosceles triangle, is equal to half into base into height, that is half into BC into AD. The value of BC is A, and value of AD is root over 4A square minus B square by 2. Then finally, we get the area of this triangle is B by 4 root over 4A square minus B square. The proof of this formula is also very important for your exam. Next, now we will solve one question. This is question number 5 from exercise 16.1. Here the question is, if the length of each side of an equilateral triangle is increased by 2 meter, its area is increased by 6 root 3 square meter. This is given, and question is find the length of each side of an of the equilateral triangle. So it will be side of the equilateral triangle. So here we can see an equilateral triangle whose length of each side is A. Then area that is, if length of one side is A of this equilateral triangle, then its area will be root 3 by 4 A square. If length is A meter, then its area will be root 3 by 4 A square meter. So if the length of one side of this triangle is increased by 2 meter, then this length becomes A plus 2 meter. We can see in the figure also the greater triangle whose length of one side is A plus 2, then its area will be root 3 of 4A plus 2 whole square. That is, we know the formula. If length of one side of equilateral triangle is A, then its area is root 3 by 4A square. Similarly, if length of one side is A plus 2, then its area will be root 3 by 4 A plus 2 whole square meter. So according to the question, in the question it is given that difference of these two area is 6 root 3. So we can write the area of the greater triangle minus area of the first by smaller triangle is equal to 6 root 3. So at first we take common root 3 by 4 from left side. Then we get common root 3 by 4a. Then we get a plus 2 whole square minus a square. And therefore we can cancel root 3 from both sides. Then we get by the formula of a plus 2 whole square, a square plus 4a plus 4 and minus a square, and root 3 cancel from both sides. And then if we shift 4 from left to right side, then it becomes 6 into 4, that is 24. So from left side here a square is cancelled. So here we get 4a plus 4 is equal to 24. From this finally we get a is equal to 5. That is, here a is the length of each side of equilateral triangle. So therefore we can say that length of each side of the equilateral triangle is 5 meter. Okay, my dear friend, now I want to give a homework is the length of each side of an equilateral triangle is a. This is stem. Then question number A. If the length of equal sides of an isosceles triangle is 4 centimeter and the length of the base is 5 centimeter, then find the area of the triangle. So already I have discussed the area of an isosceles triangle. So using that formula easily you will solve this problem. Then question number B, find the area of the triangle. That is, this triangle is the triangle of the stem. That is, you will find out the area of the equilateral triangle. Then question number C, if the length of each side of an equilateral triangle is increased by 1 meter, its area is increased by 3 root 3 square meter, then find the value of A. So this is your homework. So like number C, you can also practice another math. Other example, the question can be, if the length of each side of an equilateral triangle is suppose decreased by 1 meter or decreased by 2 meter, then question maybe its area is decreased by suppose 3 root 3 square meter or 5 root 3 square meter, then find the value of A. That is, if it is increased, then in second case length of each side will be suppose a plus 2 if 2 meter is increased, and then area will be root 3 by 4 a plus 2 whole square. And if it is decreased, then area will be root 3 by 4 a minus 2 whole square. And in that case the area of first triangle will be more. So in that case first area will minus second area is equal to like this 3 root 3 square meter. So by this way we will solve this problem. Okay, my dear friends, no more today. Inshallah, in my next lecture, I will discuss the remaining part of this exercise. Till hope you will be fine. Thank you very much.